So hello everyone. Very good evening. Madhu says no voice because I am not speaking. Generally, I wait for 2-3 minutes so that more people join. Otherwise, I have to repeat. So we'll wait for the people to get settled and then we'll proceed with the class. Okay. In the meanwhile, Kintan has thrown me a doubt. So Kintan, I will take this up at the end of the session. So any doubts you have, feel free to ping me. No, it's fine. Email, okay. My email is here in the chat. GitHub code of intermediate batch. So we don't have any repository for the intermediate code. Like the intermediate batch is language agnostic, so we don't really have a code repository for the batch. Can I ping you on Slack? So preferably you should email me. I check email more frequently. So Slack sometimes it gets lost in so many messages. If something is urgent, critical to you, please email me. All right. So welcome to today's session. So today we are going to solve a mixed variety of problems. Okay, and name of the class is interview problems. So that means these kind of problems you can uh, expect in interviews. So interview problems on arrays. So we'll be solving various problems. Okay. So I am using a different application today. It's not same as the last class. It is the one we have been using so far. Okay. Uh, what is the reason for using widescreen? Yes, the attachment would be readable this time. I also saw the PDF was not able to. PDF was not having the black background and it was not readable. But I'm using the other app, the Good Notes, and today's PDF will be as it is as I write. Okay, so it will be the same. So you will not face any issue with the PDF. So it was the other app. I was using it for first time, but this app is working fine. Okay, I've checked. So PDF will be good. You will not face any issue. Okay. Okay, I will not. I will try to avoid yellow. So maybe instead of yellow, we can put white. So red, green, and white. Maybe little peach. This is okay, right? So today we are going to solve very interesting problems, and I'm going to start with the first question. So the question is called as mango trees. How many of you like eating mangoes? Okay. All right. So it's summer season and mangoes are here. So there is a n cross n form. Okay, there is a n cross n fruit form, and That means, and you have mangoes at certain coordinates, okay, and there are some number of mangoes at every location. So for example, this location has 3 mangoes, this location has 2 mangoes, this location has 5 mangoes, this has 1 mango, this has 2 mangoes, this has 1 mango, this has 7 mangoes, maybe this has 6 mangoes, and maybe this has 4 mangoes. Okay. So now what happened? Uh, you went to the farm with 4 friends, okay, and you decided, okay, you will cut the form into 4 parts. Okay, so you will make 2 cuts in the form. That means one horizontal cut and another cut that will be a vertical cut. Are you getting it? So an example of a cut could be, for example, you decided, okay, we will make a cut at from this point. A horizontal cut would look something like this. A vertical cut would look something like this. Now what you get? So these cuts will give you how many quadrants? That means you now have 4 quadrants, okay, and you had 4 friends, okay. So that means each friend will get 1 quadrant. Yes or no? So effectively, each friend will get the sum of mangoes in 1 quadrant. Sum of mangoes in 1 quadrant. Okay. So quadrant means this part. So like if I have a square and I make 4 parts out of it, so this part is 1 quadrant. This part is another quadrant. This is another quadrant, and this is another quadrant. So Q1, Q2, Q3, Q4. So can you tell me in the current example, how many mangoes are there in each quadrant? For example, in let's say Q1, Q2, Q3, and Q4. So what is the sum of mangoes in each quadrant? So Q1 will get 6 plus 1, that is 7 mangoes. Q2 will get 2 plus 3, that is 5 mangoes. Q3 will get 1 plus 5, that is 6 mangoes. And Q4 will get 4 plus 2 plus 7, that is 4 plus 2 is 6, and 7, 13 mangoes. Okay. Now what will happen is your friends are greedy. Okay. So your friends, they are greedy. So what happens when the people are greedy? Which quadrant will pick? They will pick which quadrant they will pick. So your friends are greedy. So your like so you went with 3 friends actually. So including you, there are 2 people. So your friends will pick the quadrants with highest number of mangoes. So this will go to a friend. This quadrant will also go to a friend, and this quadrant will also go to a friend. So eventually you will get the lowest one. The lowest one is the one that you will get. Okay. But now the thing is, you are a programmer, okay, and what you can do, can you optimize for your mangoes? So my question is, can you maximize your minimum mangoes? Does this question make sense? Can you maximize your minimum can mangoes based upon cut? Okay, based upon cut. Not getting, change the cut, right? So basically, now suppose in the same example, let's say, so what has happened? Uh, you can change where should I cut. Now you have the option to cut anywhere, right? For example, uh, you can actually cut at this index. You could have said that, okay, if I cut it here, maybe I make a cut here and here instead of the white line. If I suppose make a cut here and here, what are the mangoes that I'm getting? uh, so this quadrant is how much, this quadrant is how much, this quadrant is how much, this quadrant is how much. So I'm getting 1 mango, 9 mangoes, 7 mangoes, 9 and 3, that is 12, and 2, 14. So if I make a cut at this index, the minimum mangoes would be 1. So I'm getting only 1 mango. So this cut is definitely better than this cut. Okay, it's not better. So now you have to cut in such a way that you will get the maximum possible mangoes by making a cut. Okay, so I don't know what cut would be best in this example, but I want you to come up with an approach that will tell me, okay, what is the maximum possible mangoes we can get by making a cut. Which quarter I will get? So you will always get the minimum one. You will always get the minimum quadrant. That is for sure. So whatever cut you make, you will always get the minimum quadrant. Your friends will get maximum of all. Yes. So your friends will always pick the maximum, as your friends are greedy. What if more than one quarter has uh, same number of mangoes? That is okay. In that case, you can still find the minimum. Okay. For example, if it is 6533, so you will get 3 mangoes. Ankur says this is unfair. Now, is the question clear now? Is the question clear now? Mangoes are costly, yes. Mm-hmm. Mohammed says maximum 2D subarray. Mm-hmm. So just think of it. What could be a possible way to solve it? Question is not clear. Okay. So Aman, I will give you a very simple example. Let's say I have a quadrant. Okay. I cut it into, let's say, I can make a cut here. I can also make a cut here. So it is up to me na, where I can make a cut. Let's say after making cut, the sum of mangoes in this part is 5, 6, 7, and 3. If I make a cut here, let's say the mangoes are 4, 7, 8, and 2. Okay. So now, how many mangoes I will get in this cut? What I'm going to get in this cut? Of course, the minimum. So the minimum is 3. Okay. If I make a cut here, what is the minimum I'm going to get? I'm going to get a 2. Let's say I have one more example. If I make a cut here, let's say, and here, let's say this is 7, this is 8, this is 6, and maybe this is 4. So how many mangoes I'm going to get in this case? So I'm going to get 4. So what would be the final answer if I have only these 3 options of cutting? Each cell has some mangoes. Yes. So each cell has some mangoes. And if the mangoes are not present, it means that cell is 0. So the number is either some number of mangoes or it is 0. Got it? If the mangoes are not present, then it is 0, right? So in this case, I'm uh, so what is the best I can get out of these 3 cuts? So if I have only 3 options, so this would be the best cut. This is the best I can get. Got it? Is the question clear now? So we have to cut the field in such a way that we can get our best possible number of mangoes. So in other words, cut the field in such a way that we get maximum possible mangoes. Sheetal says scroll up. This part, and it is also given that you can make cut anywhere. You can make a cut anywhere, but there should be only one horizontal cut and a vertical cut anywhere. Can we cut at I equal to 0? Uh, the cut should start from at least yeah, I equal to 0 0 would mean that you are making a cut here after the 0th row and the 0th column. A cut would mean here. See, you have to make 2 cuts. It's not about 1 cut. In order to have quadrants, you have to make 2 cuts. Okay, what could be a brute force solution? What could be a basic solution? I do not know what is the best cut. Cut at each each ij. Okay, so absolutely correct. Absolutely correct. Make a cut at every x comma y. Okay, so let's say I have n number of rows, I have n number of columns. So I say, okay, in the grid, whatever is possible coordinates, I will make a cut. So in the first iteration, I make a cut here. I say, okay, I'll cut it like this. What I need to do? I need to say, okay, I'm going to make a cut at every xy. So how many ways we can make a cut? Come on, tell me. N square ways. There are n square ways of making a. So I can say, okay, for x equal to 0, x less than n, x plus plus. All right. I can say for y equal to 0, y less than n, y plus plus. Okay. I said, okay, I made a cut at x comma y. So if I made a cut at 0 0, what happens now? Can I count the number of mangoes in each quadrant? Can I count the mangoes in each quadrant if this coordinate is x comma y? So how do you count mangoes? Can I say the mangoes in Q1 would be from 0 0 to x comma y? Okay. If I say this is Q1, the mangoes in Q2 would be the sum of mangoes in this quadrant. Q2. So how many mangoes I will have in Q2? Can I say Q2 starts from the same row if this is the X row, but it starts from the next column, Y plus 1. If this column is Y, the next column is Y plus 1. So this coordinate from this cell to this cell. Basically, we want to iterate on this part. This is quadrant 2 to the same row till the last column. So same row and the last column, X comma N minus 1. Are you getting it? Okay. What is Q3? Let's say I want to count the mangoes in this quadrant. From, see, it is given in the question. We it's not necessary, but just it's given in the question, so we are assuming it. So what is the number of mangoes in Q3? So I need to sum all the values in the array that is starting from uh, X plus 1th row, the yth column, to this row that is the N minus 1th row and the yth column. Yes. And what is the number of mangoes in this quadrant? So one way could be that out of total mangoes, if I subtract Q1, Q2, Q3, I will get the total mangoes. Does it make sense? Can I say that Q4 is simply nothing but the total mangoes I have in 2D array minus Q1 plus Q2 plus Q3? That is one way. Or you can say it is the mangoes from this cell. So this cell is X plus 1 comma Y plus 1 till the last cell, that is N minus 1 comma N minus 1. Okay. How we are going to get the total mangoes? So total mangoes you can store in the beginning. You can say, okay, total is sum of every array ij. You can compute using two loops in the beginning, right? So total is pre-computed. Got it? Now, now you know that, okay, I have four options. What option I'm going to get? What option I'm going to get? In every cut, how many mangoes I'm going to get? Minimum of all. Absolutely yes. So what I can say is that the number of mangoes I will get is minimum of Q1, Q2, Q3, Q4. And maybe I can keep a variable that, okay, the maximum mangoes I can get is, let's say, 0. And every time uh, I see, okay, if mangoes is greater than maximum, the maximum I have seen so far, I will update the maximum. Does it make sense? So that means out of all possible cuts, I'm first choosing the minimum, and then out of all minimums, I am choosing the maximum. So effectively, what I'm doing, I am doing maximum of all minimums. Does it make sense? Okay. So this code will work fine, and it will give me the maximum mangoes I can get in the best possible cut. Okay. Now, what is the time complexity of this code? What is the time complexity of this code? See, this loop is running n times. This loop is also running n times. How much work we are doing here? How we are computing this? How we are computing this sum? How we will compute the sum? Who will tell me? One loop or two loops? So we so so Rishi, we are actually cutting at every quadrant. Okay, we are making a cut at every intersection. We are making a cut at every possible intersection. So now if you are computing this sum, let's say you are using loops. So you might be using loops. You might be saying, okay, I will iterate on this part of the array to find this sum s1. I will iterate on this part of the array to find this sum s2. I will iterate on this part of the array to find some s3. I will iterate on this part to find some s4. So how much work you have done in total by traversing the entire array here? So some would also take how much time? Some would take n square time. Yes or no? The sum itself is going to take n square time, right? So in total, you are computing this sum how many times? Sheetal is not getting. So Sheetal, see, for every possible cut, if the cut is here, let's say, what you did? You said, I will traverse this array like this, like this, like this, like this to find out the sum of the four quadrants. And I said, you have n square such cuts. Are you getting it? So the overall complexity would be order of n power 4. Why? Let's see again. See, you have what you're doing. You are making n square cuts. Okay? And for each cut, finding what is there in each quadrant. Each quadrant, that also takes n square time. So in total it will be how much? N square into n square. So it is order of n4. See, I have not written the loop for the sum. Eventually you would be using a loop, right? Does it make sense? Sheetal? Sheetal says got it. Okay, what about other people? Uh, but four quadrants, right? Okay. Did not understand how we calculate Q3 and Q4. Right. So let me show you. Let's say there is a function called sum in which you are getting an array. You're getting some starting point x1, y1, and you're getting some ending point x2, y2. So I say, okay, if I have an array in which you have to find out the sum starting from a point x2, y2, and you have to iterate till, sorry, x1, y1, and you have to iterate till, let's say, x1, x2, y2. Okay, some part of the array, right? So what you will do? You will simply put two for loops, a for loop of x, a for loop of y, and you will say sum equal to sum plus array of xy, something like this. Does it make sense? Okay, so this is how the sum function will look like. So that's why I'm saying that sum function itself is a n square function. And you know the bounds. The bounds will be rho will go from x1 to x2, and y will go from y1 to y2. So these are the values of x1, x2, y1, y2. We can make 2n cuts. Why 2n cuts? If I give you a 3 cross 3 array, so you make a cut here, you make a cut here, you make a cut here, you make a cut here. Okay, So so the minimum cut that you're making is at 0 0. Okay, and you're not making cuts in the last row. So last row you don't need to make any cuts, otherwise for all positions you need to make cuts. So last row and last column you can ignore. You can say, okay, I do not need to make cuts here, but for all other positions you need to make cuts. So it is roughly n square. Okay, it's roughly n square only. Siddharth, see, out of n rows you can choose any row to make a cut. You can say, okay, I will make a cut here, or you can say I will make a cut here. Out of n columns, or sorry, it was columns. Out of n rows you can choose any row. You can say I will make a cut here, or I'll make a cut here. Okay, so effectively it will be n minus 1 into n minus 1. We ignore the last row and the last column, so it would be square of n minus 1. These are the actual cuts that you're making. So you can say less than n minus 1, y less than n minus 1. Does it make sense? Siddharth just got it. Great. All right. Now, can we optimize this somehow? Is there a way we can reduce the time complexity? Ranjit says, but for Q4, we are not traversing. Yes, we are not traversing. So even if you're computing these three values, it would be of the order n square. Okay. It would still would be of the order n square. Yeah. We can use prefix sum for each row. Vinay, you are thinking in the right direction, but little better. I want you to think little better. Sliding window? No, not really. The hint is towards prefix sum. Okay, think in terms of prefix sum only. Instead of one dimension, think in terms of two dimensions. Okay, prefix sum, and okay, let's do a 2D prefix sum stuff. So what I will say, that I will create another matrix in which a particular cell xy will store the sum of all the fruits starting from 0 0 till the sum of xy. Does it make sense? That okay, I'm going to create a matrix called sum, and sum of xy will give me the sum of all mangoes in the region from 0 0 to x comma y. Does it make sense? Okay, now look at this and tell me what will be uh, the value in the first cell. What will be the values in the first row, let's say? So here it would be 1. What about this cell? How many mangoes in this cell? The sum of all mangoes till this point. Okay, so it will be 1 plus 2, that is 3. Absolutely correct. And this would be also 3, because this cell is storing from 0 0 till this cell how many mangoes I have seen. Great. What about this cell? Okay, so it will be 1 plus 3, that is 4. Absolutely correct. What about this cell? So from 0 0 till this cell. So how much it would be? So it is 3 plus 1 4 plus 2 6 plus 2 8. Okay, are you getting it? How much here? So it would be uh, 8 plus 4 12. How much here? It would be 1 plus 3 4 plus 1 5. And how much here? So it would be 8 plus 5 13 plus 5. uh, no, 8 plus 1 9 plus 5 14. So it would be actually 14. You can verify, right? Now my question is how I can build this formula little efficiently, how I can calculate the value of s of xy, how I can build this matrix. And let's say this is my farm. Sheetal says one more time. Sheetal, I'm telling you that m of xy will store the sum of mangoes from 0 0 till x comma y itself. So I'm building this. Okay. Now let's look at it like this. So if I'm suppose computing m of xy, okay, let's say I'm computing this particular cell. So what value will be stored here? So this would be m of x minus 1 and y. Does it make sense? Come on, let me know. Yes. And what does this value represent? It represents the sum of all mangoes from 0 0 till this point. Yes or no? And what is this value? Can I say this value is m of x comma y minus 1? So what does it represent? It represents the sum of all mangoes from 0 0 till this point. Yes or no? Okay. And what about uh, this cell? Can I say this is m of x minus 1 y minus 1? What does it represent? It represents sum of mangoes in this region. Do you see a overlap here? Can I say that if I add green and yellow and subtract the common part, I will get green plus yellow minus red and plus the mangoes here. Whatever is the number of mangoes here, it will give me the sum of mangoes at s of x comma y. Can I say plus form of x comma y? This will give me the sum of mangoes at x comma y. Does it make sense? So what is green? So it is m of x comma y minus 1 plus yellow, that is m of uh, m is actually your s, right? So let me just write this matrix as m only, m of xy. So m denotes the sum. So matrix of x comma x minus 1 comma y minus m of x minus 1 y minus 1 plus the actual array form of x comma y. Farooq says, can you please repeat? So who all understood this? How many of you are confused? See, it's very simple. Let's say I have a rectangle. Okay. I know what is the area of this rectangle. Let me call this as green. Okay. I know the sum of this rectangle, okay? I also know the sum of this rectangle, okay? What I want to do, I want to find out the sum of the bigger rectangle. So how I can get the sum of the bigger rectangle? Who will tell me? Sum of elements in the bigger rectangle. So this is only one cell. So this cell is, we know, okay, there are 3 mangoes here. So how you will get? See, if you add green plus yellow, what part is the overlap? You have to subtract the overlap now. So this area is counted twice. This red part is counted twice. Yes or no? Okay. So if you do green plus yellow and you subtract red, what do you get? You get this much area, right? Except the last cell, you get, okay, this is the sum in this matrix. So if you want to include this cell in the sum, so what you should do? You should add how many mangoes are present here. If there are 3 mangoes, I will add 3 here. Does it make sense? Are you getting it? So what we are doing nothing but we are actually calculating a 2D prefix sum. And this is the formula to calculate the 2D prefix sum. But we are dividing at each ij, so how it will overlap? See, right now we have not talked about cuts. I'm just telling you that how do you compute this matrix? See, I want to, suppose I want to calculate the number of mangoes at this point. One way is you go and find out the sum manually. You say, okay, I will do 1 plus 2 plus 0 plus 3 plus 2 plus 4 plus 1 plus 5 plus 6. Tell me what is the answer. Tell me what is the answer. Okay, so people are saying 24. But I'm telling you that this is expensive because you are using loops, and loops are expensive in terms of time. I told you a shortcut. I said, okay, don't worry. You add this element, you add this element, you subtract this element, and you add this element. So if I do 12 plus 14 minus 8 plus 6, what answer I get? Come on, tell me. 12 plus 14, 26, minus 8, 18, 18 plus 6, 18 plus 6, 24. I get 24 here. Okay, now this is a order 1 operation. Are you getting it? And earlier it was a order n square operation. Are you getting it? So we actually optimized our calculation of sum for every bucket to once. Okay, let's calculate for this rectangle. Okay. So this the formula would be a little more simpler because we don't have anything at y minus 1. So it will be simply see, it would be simply whatever is the number of rectangles, number of mangoes you have seen till the previous bucket plus the current bucket. So it would be 8 plus 5, that is 13. Okay. How do we calculate this bucket? Can you tell me how many mangoes I have seen in this particular cell? So that answer will be stored in this bucket. How do I calculate this? 14 plus 13 minus 5 plus 9. So 14 plus 13 minus 5 plus this 9. So it is 27 minus 5, 22 plus 9, 31. Let's verify. So 1 plus 2 is 3, 3 plus 3 is 6, plus 2 is 8, plus 1 is 9, 9 plus 5 is 14, plus 8, 22, and 9, 31. So we are getting 31 mangoes. Okay, so this again is a order 1 operation, whereas this is a iterating and finding is a order n square operation. Okay, what about this bucket? Can I say it is 24 plus 31 minus 14? So 24 plus 31 minus 14 plus 10. So whatever it is. How much it is? Who will tell me? Okay. People are saying 51, so let's assume it's 51. So did you understand this formula? So right now the question is not complete. We just have built a prefix sum matrix. So step 1 of the problem is to build a prefix sum matrix. And how do you build it? You say, okay, I will iterate over every x. Okay, so x goes from 0 till x is less than n minus 1, x plus plus. I go to y. So initially I had a matrix of n comma n, and that was initially 0, right? So now I just need to put this formula here that uh, so right now we are not making any cuts. We are just computing a prefix sum matrix. Let's see how this matrix will help us. M of x comma y. Okay, great. Now step 2 is about making cuts. Make cuts. So what is the complexity of generating this prefix sum matrix? Who will tell me? Order of n square, absolutely correct. And what this matrix is telling me that if I have a cell m of x comma y, so m of x comma y tells me the total sum of mangoes starting from 0 0 till this particular cell. This is what I know, right? This is what I know. Great. Great. Now the question is make cuts. So how many possible cuts we can make? So again, we can iterate over all possible values of x. We can iterate over all possible values of y. Okay. And we will make a cut. We'll make a cut at x comma y. So making a cut will give us 4 quadrants. Let's say this is q1, this is q2, this is q3, and this is q4. And suppose I made a cut at x comma y. So who will tell me how do I get the number of mangoes in Q1? How do I get the number of mangoes in Q1? Tell me. Simply access that element. So can I say the number of mangoes in Q1 is m of xy? Because m of xy stores the sum of elements in this part. Yes or no? Earlier we were using 2 loops, but now it's a order 1 access. What about how do I get the number of mangoes in Q2? So what is this number storing? It is actually storing all the elements in this part. Yes or no? It is storing from 0 0 till this part. But I want to remove the elements in Q1 to get these elements. Does it make sense? Okay. So can I simply say that it is nothing but what is this? What is this cell? M of the row is x. What is the column? The column is n minus 1. M of x comma n minus 1 minus q1. That will give me the number of apples in Q2. So this is what I will get. Does it make sense? The green part. Come on, guys, let me know. Are you getting it or not? Okay. How do I get Q3 then? Who will tell me Q3? Okay, so Q3 is nothing but, see, in this rectangle, we want to find out the sum of this part. So we already know that this box is in the last row, so it is m of the last row, that is n minus 1, and the column is y. So this cell is storing the total sum of this part. So if I subtract q1 out of it, I will get the number of mangoes in q3. Does it make sense? Okay. What about q4? So q4 is nothing but the sum of mangoes in this part. Okay. Which is m of n minus 1 comma n minus 1 minus q1 q2 q3. So minus these quadrants. Great. So now you got to know that okay, these can be computed and each of them is a order one step. Yes or no? Okay, and finally then you have the same logic. You have to track the minimum and update maximum like we did earlier. That is also an order one step. Okay, so finally you will get to know how many mangoes are there, right? So what is the complexity of step 2 in total? Order of n square. Great, great. And what is the overall complexity of this solution now? It's still order n square. Okay, so we are doing order n square plus n square, which turns out to be order n square. So we optimized our solution starting from order n4 with O1 space to order n square time. And how much is the space now? How much space we are using? We are using extra sum array, right? We actually calculated one additional array. So this is a new array that we created to store the sum, right? So we are taking up order of n square space as well. So we improved the time, but our space complexity got disturbed, which is okay. Time is more important than space. And yeah, so this is actually an example of a 2D prefix sum. So did you understood this concept of 2D prefix sum and how it can help you to optimize the problems in which you have to find sum of quadrants? Got it? No, it's not complex. It's simple Venn diagrams. Have you studied Venn diagrams in college or in school? Let's say there is a set A, there is a set B, there is an overlap, right? So how do you find A union B? So it is nothing but number of elements in A plus number of elements in B minus the elements which are common, A intersection B. So it is a simple application of Venn diagram. Okay, so I know, okay, there is a quadrant this, there is another quadrant. If I want to know what is the sum of both quadrants, so I have to say, okay, A plus B minus the common part, because it's getting repeated. It is counted 2 times, right? Long time ago, right? Mohammed says speech array again to get more clarity. Okay, all right, so let's try to build this array using the formula, right? See, if you're in the first row, right, if you're in the first row or if you're in the first column, the funda would be very simple, that a of 0 0 will be equal to this element 1. Great. Now you're talking about this entire grid, how many mangoes are here. So what you simply need to do, you need to say that I will add to the previous bucket, which is 1, whatever I get in this cell. So it would be 3. So what is the number of mangoes in this region? It is I know, okay, till the previous point the mangoes are 3. So in this 3, I can simply add what I have in the current bucket. So it is 3 plus 0, it is also 3. Okay. And similarly, along this column, you just need to take up the sum. So you need to say 1 plus 3, it's 4. 4 plus 1, it's 5. So what does this 5 denote? So 5 denotes the mangoes in this region. 3 plus 1 plus 1. So how do you get the mangoes in this region from here to here? You don't need to sum all the elements. You just need to take the previous element, that is 5, and add the current 8. So it will be 13. Okay. Now for these regions which are here, starting from index 1 comma 1 to n minus 1 comma n minus 1. So here, if you are calculating for this grid, what do you need to say? You need to say, okay, all the mangoes in this region plus the mangoes in this region minus the mangoes which have been counted twice, which are these mangoes. So where this information is coming from? So 3 plus 4 minus 1. So 7. 3 plus 4 is 7, minus 1, 6. And how many mangoes at this bucket? So 2. 7 plus 2 is 9. Oh, sorry. 3 plus 4 is 7, minus 1, 6. 6 plus 2 is 8. So there are 8 mangoes here. So if you even find out the sum, so 2 plus 2 is 4 plus 3, 7 plus 1, 8. So there are 8 mangoes in this. So are you getting it? Okay, so this is what we are doing. More clear. More clear. Great. What about this cell? So 3 plus 8 minus 3. So 8 plus 3, 11 minus 3, again 8, plus mangoes at this index. So it is 12. 8 plus 4, that is 12. So similarly, we are doing it for the entire matrix, and hence we get the prefix sum matrix, right? Got it? Okay, great. Okay, I'll try to increase the font size. What is form xy in the formula? Form xy is the original array. I'll just call it as array, okay? The original array. While doing 2D prefix sum for 0, 0, if we do m of x comma y minus 1, will it be 0? See, uh, you need to handle cases separately. See, for 0, 0, these indices do not exist. They don't exist. So for m of 0, 0, your answer would be nothing but it will be equal to ARR of x comma y. So if one of these index does not exist, take that value as 0. Shri Vidya, are you getting it? Even for something like m of, let's say, 2 comma 0, that means this element. So I know that this element does not exist, this element does not exist. So my answer would be just simply this element plus the value at this index. So you have to take these values as 0 or you have to ignore them, right? Got it? So m of 2 0 would mean that sum till this index which is stored here plus this element. So it would be nothing but m of 1 0 plus array of 2 comma 0. Yes, it is based upon the condition. So first row, first column, and the first bucket, they will have these conditions. Right. Vinay, you are right. Union minus intersection plus value. Right. Okay, so let us do a question on 1D arrays. Given n array elements, we have to find maximum subarray sum of length n, of a subarray of length that is equal to k. So now you are explicitly given that there would be a subarray whose length is now fixed to k. Okay. So for example, if I have an array that contains, let's say, 10 elements, minus 3, 4, minus 2, 5, 3, minus 2, 8, 2, minus 1, and 4. Okay, first tell me the most basic approach. What would be the basic approach? Find sum of every subarray possible. Okay, so very basic would be find all subarrays. How many subarrays you will have? N square. Then you check uh, how many subarrays of length, how many subarrays have length exactly equal to k. Let's say k is 3. K is some number that is 3. So you will check, okay, how many subarrays I have. Let's say a given subarray follows this property, and then you find out the sum of that subarray. So how much time it will take to find out the sum? So you actually do not need to find all subarrays, right? uh, you can directly find out all subarrays of length k. How? If you know, okay, the starting index is 0, you know where is this subarray going to end? See, if the starting index is 0, the subarray will end at index 3. Yes or no? There is only one option. There is only one option for the subarray because now the length is fixed at 0. What about if you start from 1? Where is the subarray going to end? It's going to end at index 4. See, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So if you start from index 1, the subarray will end at okay, it will end at index 3, right? Yeah, I made a mistake. The subarray will end at index 2 in this case, and it will end at index 3. So if you start from index 2, it will end at index 4. Okay. So similarly, if you start from the ith index, the subarray will end at I plus k minus 1. Does it make sense? Right. So now what you need to do, you need to go to every such value. You need to say, okay, for I equal to 0, I less than what should I write here? So I should not go beyond this index because I know the ending point, right? The ending point is, let's say if it is 9, so it should not go beyond 7. because after that I will not get a subarray of length 3. So this is n minus 1, this is n minus 2, and this is n minus 3. So I should be less than equal to n minus k. Does it make sense? Now I know the ending point is what? The ending point of the subarray is what? What is the j? Where is the subarray ending? So j is equal to I plus k minus 1. Absolutely correct. And now I can find out the sum. Can I say sum is 0? And I can iterate from uh, I to j to find out the sum of the subarray. Sum equal to sum plus array of k. And if I see the sum is greater than the largest, I can update the largest. Yes or no? This is what you can do. So you see, if sum is greater than largest, I update the largest. So what will be the time complexity of this code? So this is the first subarray you will get. This is the second subarray you will get. This is the third subarray you will get. So this loop is running approximately n minus k times. So let's say it is running n times. We don't have a loop for j because the ending point is fixed. What about this loop? So can I say in the worst case or in every case it's going to run k times? Yes or no? Because the subarray only has k elements. It does not have n elements. It only has k elements, and k is given in the question. So come on, guys, let me know. Does it make sense? Of course, yes. So the time complexity would be order of n into k. Because k is a variable that is given in the question. K can be n, k can be 1, but we don't know. So it's better to write that this loop runs k times and the outer loop runs n times. So it is going to be order of n into k. Great. Can we do better? See what we are doing, how we can optimize this. Okay, using prefix sum. Okay, Shri Vidya has given us an idea that we can use prefix sum. So let's say in the step 1, I calculate, I build the prefix sum array. I say the total sum of the array till this point is same as the sum till this point plus this array element. So can I say that prefix sum of I is same as prefix sum of I minus 1 plus the current element, that is array of I. So now if I build this array, absolutely correct. The step 2 would be to find out the sub array okay. So now how do I find out the subarray? So again we have to try for all subarrays. So I goes from 0 till I less than equal to n minus k I plus plus. I know the ending point of the subarray. What is the ending point? I plus k minus 1. How do I find out the sum of the subarray from the index I to j? How do I get this sum? So can I say this sum is ps of j, and if I subtract this sum which is ps of I minus 1, I will get the subarray sum. So absolutely correct. Now the sum is nothing but ps of j minus ps of I minus 1. Otherwise, if I is 0, then you know how to handle it. So I will just leave it for you. So handle for I equal to handle when I minus 1 is negative. Okay. Sure, Sheetal, we will do it. And here now you can say I will update largest. That means if sum is greater than it. Okay. So if sum is bigger than largest, I'll say largest is now sum. So what is the time complexity of this approach? Who will tell me? Of course, it's slightly better. So prefix sum will take order and time, and this is now we are not finding the sum using a loop, so it's again order and time. So overall, it's order and time. And what about space? What about space? It's still order n because we used a prefix array. Because of a prefix array, the space is now increased to order of n. Absolutely correct. Okay. Now Sheetal is asking me to dry run. Okay, let's do it. Let's take an example. Let's say the array is 1, 3, 4, 6, minus 2, minus 3, and 7. So how you build the prefix sum array? So prefix sum array would be like this. 1, 1 plus 3, 4, 4 plus 4, 8, 8 plus 6, 14, 14 minus 2, 12, 12 minus 3, 9, 9 plus 7, 16. Okay. Sheetal, any doubts in the prefix sum array? So prefix stores the total sum at a particular index. So PS of I is PS of I minus 1 plus array I. Great. Now I told you that suppose I want to find out a subarray which starts from this index and it is of length 3. So what does it mean? It means that the sum of this subarray is nothing but the total sum this till this point, that is 12, okay, minus the sum of this part of the array. Yes or no? This minus this. So PS of j, that is the ending point, minus PS of I minus 1. Because from I to j you want to include, right? So subtract part would be this much. So this is PS of I minus 1. So 12 minus 4, it is now 8. So if you look carefully, that is 4 plus 6 plus minus 2, is it 8? The answer is yes. So earlier we were doing a loop, but now since we are using a prefix sum, it's a order one step, and hence it is a optimized. It's better than doing the other way thing, right? Sheetal says clear. Divya says, can we use carry forward as well? Yes, kind of. Now we are going to discuss a very similar thing that we call as a sliding window. Okay, let's see. Let's see what this sliding window thing is, right? Now, what I'm trying to say is that now let's say that we will first find out the sum of first k elements. How much is this sum? What is the sum of the first possible subarray? 8, right? So let's say k is 3. Great. So I know the sum is 8, right? So what I want to do in the next iteration, I actually want to find out the sum of these 3 elements. Yes or no? Yes. So can I somehow generate it from the previous sum? So this was the sum from 0 to 2. Now I'm calculating the sum from 1 to 3. Can I say this is nothing but from the previous sum that I got, you add 6 to it and you subtract the first element. You will get the next sum, that is 13. Does it make sense? So look at this. What we are trying to do, we are saying, okay, if we have a window and I want to move this window one step forward, so that means this element will get included and this element will get subtracted. So we are using this red sum that we had computed. So what was the previous sum? So in that, we are adding an element that is at index, let's say this is index I, at array of I, okay, uh, and we are subtracting this element. This would be array of I, it would be array of -1, array of I -2, and this would be array of I -3. So minus array of ai minus k. Does it make sense? See, sum of 2 comma 4 would be what? The previous sum, that is 13, absolutely correct, plus array of 4. So I is 0, 1, 2, 3, 4, plus array of, see, array of I, that is array of 4, minus array of 4 minus k, minus array of 1. So which is, now I'm calculating this sum, right? So I need to add 2 and I need to subtract this element, array of 1, that is uh, I minus k. So k is actually 3. So it is array of 4 minus array of 1. Okay. So this is equal to 13 minus 2 minus 3. So this is 8. So if you look carefully, that 4 plus 6 is 10 minus 2, this is 8, right? So what is happening? We are kind of doing a sliding window stuff. So this technique is known as sliding window. Are you getting this technique? Are you getting the idea of sliding window and why the name is sliding window? Because we have a window that is moving towards right. So whatever new element is added to the window, whatever elements move out of the window, subtract them. So it's simply a add subtract game. That's it. Now, is this approach better than the previous approach? How much time it will take? It will take only order of n time, and it will not take any extra space like prefix sum. So it will only take order 1 space, and hence this is better. Got it? Great. So this is what sliding window is, okay? Okay, Sheetal says write the code. Do you want me to write the code? Okay. People are saying yes. Okay. So what you need to do, see, for getting the first window, right? For the first 3 elements, you have to write a manual loop, right? And for the remaining elements, you can do something. You can use the sliding window. So let's see how it can be done. See, for the first k elements, let's say 0, 1, 2, right? So you need to put a loop from I equal to 0, I less than k, I plus plus. So in order to get the sum of the first window, so you have to say, let's say sum is 0. You have to say sum equal to sum plus array of I. So this gives you the sum of the first window, right? And let's say our answer is equal to sum, the largest answer, let's say largest answer. This is equal to sum because you got at least one window, right? Now what you need to do, you need to start from this index. So this index would be index k, or 3 in our case, and you need to move till this point, that is n minus k. N minus k, right? So you need to say, okay, I will start from index for mm, I equal to k, I less than equal to n minus k, I plus plus. Okay. So how do I get the sum of this window? So can I say the new sum will be nothing but sum of the previous window plus the newest element, that is array of I, minus the element that has been gone out of the window. Does it make sense? Okay. And every time what you need to do, you need to say my answer is maximum of the answer that I have, or the new sum that I have got. Should not we start the loop from 1 instead of k? Oh, right. Sorry, I made a mistake. Yes, we should start the loop from 1. Uh, or let me just think about it. Let me just think about it. What should we do? I think I had written it correctly. See, for the first window you have already computed, right? So now I'm saying that okay, if I'm talking about this window, okay, let us just think it like this. Let's say if I confused one thing. If I suppose, if I keep the starting point as this, if I keep this I as the starting point, okay, let's say the window starts at index I, or in our case the index is 1, let's say. So in that case, the starting point would be, let's say, 1 in this case. So after the first window, which starts from index 0, the next window will start from 1. So from 0 to k minus 1 we have already computed. The next window will be from 1 to k. The next window will be from 2 to k plus 1. Does it make sense? So I'm saying, okay, this window I have already computed, and for this window I'm putting a loop. So I'm changing the starting point. I'm saying, okay, start the window from 1. So when the window starts from 1, this is the element that will get added. So how do I get to know about this element? So can I say this element is nothing but array of I plus k minus 1, and the element that is getting subtracted is just the previous element. So this element is getting subtracted. See, if this is the previous window and you are saying this is the new window, this index is I, then this element would be I plus k minus 1, and this element that is going out, it will be I minus 1. So can you simply say minus of array of I minus 1? So this would be fine. And since you're starting from I equal to 1, this value would always exist. So this is the right way. Okay. Got it? And this will make sure that you do not go out of the window, right? So this will take your order of end time, and it will take order of one space. You are not taking any extra space. Okay, got it? Great. Easy. Cakewalk. Easy or very easy or not so easy? Okay, not so easy. It's easy actually. It's easy, Kintan. Just uh, think about it. You right, right. Tomorrow I'm going to my mango farm with laptop. Great. Send me some mangoes, Vinay. We are not getting good mangoes here in Punjab. All right. So do you want a break? Yes, Chirag. S- so class was little happening. We did prefix sum. So you need to go and watch the recording. Okay. You're solving customer problems, and I was solving your problems. Okay. So we did some problems involving 2D matrix, 2D prefix sum, 1D prefix sum, sliding window. Okay. So let's meet after the break, and we will uh, meet again. Okay. So changing the original array is not always a good idea. You could have done it, but I would say uh, not preferably you should avoid modifying the original input. Okay. So let's have a break. Okay. So maybe it's hot, so you have something cool, or you can have mangoes. Okay. Okay, let's meet at 10:40. Great. Ramesh, where are you, Ramesh? Bangalore? Great, great, great. Okay, enjoy the rain then. Bye bye. We'll meet you at 10:40. So, welcome back, everyone. Okay, Sheetal is back. Everyone is back. Right. So since it is raining in Bangalore, so we will discuss a rainwater problem. Okay, very popular interview problem as well. It's called as rainwater trapping problem, or yeah, so simply rainwater problem. Okay. So now what this problem says that you are given an array, and array contains the height of buildings. Let's say in this case the height is 7 followed by 0 followed by, so the black one is the building. Okay, so 0 means there is no building here. Then you have a building of height 2, 5, 0, 6, 4, 0 and 5. Okay, and then eventually let's say the buildings were looking like this, and so on, and there were rains. Okay, the rain happened, and water got trapped in between the buildings, so it somehow got filled up to this level, something like this. So you need to tell me that how much total water is trapped in the buildings. Okay, in between the buildings, so you need to calculate the total water trapped in the buildings. So for this example, if you look carefully, this is 1 unit wide. Okay, and on the top of seventh building there is no water here. Okay, but on the zeroth building, how much is the water? How much is this water? How many units? So it is restricted by the height of this building, right? So this building is restricting that, okay, this much water can be stored here. So it is actually 6 units. Absolutely correct. How much water is here in this part? 6 minus 2, it's actually 4 units. Absolutely correct. See, what you need to know is how much water is trapped here. It's the height of the water up to a certain level, and minus the height of the building. So it's 6 minus 4. That's absolutely correct. So in this building, you have 6 minus 4, that is 2 units of water, and here you have 6 minus 0, that is 6 units of water. Absolutely correct. How much water is in the this building? Okay, it will be 6 minus 2, that is 4 units. Absolutely correct. How much water here? 6 minus 5, that is 1 unit. Okay, and here again it's 6. Here it is 0. Here it is how much? Now for this building, the water is restricted by this building. Do you see? It's correct. For this building, the water level is restricted by the building here, right? So it is 5 is the water level minus the height of the building, that is 1, and again it is 5, and here again it is 0. So if you add all of this water up, so it will be 6 plus 2 plus 4 plus 1 plus 6 plus 1 plus 5, 8, 4, 12, 13, and 6, 19, 20, and 25. Absolutely correct. So the 25 units of water is trapped in this building array. And now given this array, you have to build a solution that works as a code. So right now we did it in a visual manner, but think of an algorithm that we can use to compute this water. Just think of it how you can solve this problem. See, one idea is very clear, that we know we need to know the water for the ith building. If I figure this out, I can add it for all the buildings. Yes or no? If I know, add for every building. Okay, so the main point is, how do I find out how much water will be trapped on the top of a ith building? So if I have a building here and I have some buildings on the left of it, some buildings on the right of it, how do I get to know that how much water will be trapped on the top of, let's say, this ith building? Who will help me in this? How much water will be trapped on the top of this building? Ramesh says largest number. Right. See, now if there is some water here, right, it has to be restricted by some building which is higher, which is tallest on the right, or which is tallest on the left. Does it make sense? What I'm trying to tell you. See, if there is some water that will be stored. Now, if there is a building, and if it is a tall building here and a smaller building here, then this building will decide the water level, right? But if it is the other way around, and you're talking about this building, again this smaller building will decide the water level. So that means that for this IS building, we need to see in this most part, what is the largest building that is present. Yes or no? I call this as, let's say, B2. I also need to see what is the largest building present in the leftmost part. I call this as B1. Yes or no? And I call this as BI, the ith building. So how much water will be trapped for BI? It will depend upon which of these two buildings has a lesser height. Yes or no? So the minimum of B1, B2. Okay. The minimum of B1, B2. So in this case, this is B1 and this is B2 for this building. So the minimum of these two will decide the water level, the height of the water. And if I somehow subtract the height of the building, BI, okay, that means the building height of the current building, that will actually give me the storage. This will give me how much water is stored. Yes or no? For BI. So if I know this BI, I need to add it for all the buildings and get it done. So can you think of an approach using which we can now solve this problem? What should we do? How many loops we will need, or what will be the time complexity? Or is there something we can do to improve this? So just think about it, okay? Take a pause, think about it. Or if you want to implement this as a solution, what code you will write? Just think about it. How do you find the maximum for every eye that is to the left of it and to the right of it? And it is also clear that the first building will never hold any water. Yes or no? The first building will never hold any water. Okay, there would be some water here, which is okay, but the first building will never hold any water. Similarly, last building will never hold any water, right? Yeah, that's correct. Okay, let us try to write a loop. Let's say I will go from uh, the first building till the n minus 2th building. That means the second last building. Okay. Can I say that for this, find the largest element? So B1 is find the largest element in the range I plus 1 from 0 to from 0 to what? I minus 1. Does it make sense? The B1 is nothing but the largest element in the range 0 to I minus 1. So Sheetal, see, there is no way you can stop the water, na? Whatever is the height of the first building, the water will not hold there because there is nothing on the left to stop it. Are you getting it? Similarly with the last building, irrespective of height of the building, there is no way you can trap the water on the last building because it will flow down. Got it, Sheetal? Okay. So I'm starting from 1, right? So can you say how do you find the largest element in the range 0 to I minus 1? So one way is you can use a loop. Yes or no? What is B2? You can again find the largest element in the range I plus 1 to n minus 1. Again, you can use a loop. Okay, then the water for the current building, it would be how much? Let's say the total water is 0. So can I say the total water will be nothing but water plus the current water? The current water would be nothing but minimum of B1, B2. That will decide the water level minus the height of the current building, BI. Okay. Okay. Instead of doing this, you can do it from 0 to I, and you can do it till from I to n minus 1. I will tell you why. From 0 to I would mean, for example, uh, you're finding, okay, what is the largest building to the left of it, and what is the largest building. Let's say this height is 3 and this height is 5. So what you will get? B1. So I'm saying take the largest including the current building. So what would be B1 for this building? Let's say this is 6, this is 8. What is B1 for this building? Ith building. Come on, tell me. From 0 to I. So between 3 to 5, what is B1? What is the largest building to the left of 5 including 5? Of course it is 5. Okay. What is B2? What is the largest building to the right of 5 including 5? 8. 8 is the largest building, right? Okay. What is minimum of B1, B2? It is 5 and minus BI. So 5 minus 5, it will give me 0. So it will actually handle the case where the building is not storing any water and the building itself is the largest. So you can say from 0 to I and from I to n minus 1. Okay. So this will solve the problem for you. And finally, you can print how much water I got. Does it make sense? We are adding water for every building. Come on, let me know. Does it make sense? Sheetal, what we did? How much water the current building is holding? The last part, right? See, what I told you that if you say I have a building and the largest building here is, let's say, 8, and the largest building here is 6, and let's say these are smaller buildings, 5, 3, 2, 7, 1. Okay, so how much water will be present on the top of this building? It will decided by 6. That means whatever I have here which is smaller than it, I don't care about it. Okay, I don't care about these buildings. So for this building 2, what is the largest element in the range 0 to I? So that element is 8. What is the largest element in the range from I to n minus 1? That element is 6. So who is going to decide the water level? The minimum of 8 and 6. So that is 6. How much is the actual water height that will be there? So it will be 6 minus the height of the current building, BI. So that is 2. So this value would be 4. So that is what I'm doing here. I'm saying the water level minus the building height. That amount of water will be added for the current building, and I added for all the buildings from 1 to but some amount of water can also be stored between 6 and n minus 1. What if the center building is 7? Of course, no issues. Let's say if I talk about this building 7, right? So what is the largest in the left? That is 8. What is the largest in the right? That is 6. So how much water it is going to hold? So again, minimum of 8 comma 6 minus 7. So it will hold 1 unit of water. And yes, it is holding 1 unit of water. Sorry, uh, I just did it wrong. The 7th building is not drawn correctly. I mean, including the current building, okay? So I'm saying that including the 7th building, what is the largest building to its right? From 7 till the end. So it is 7. What is the largest building to the left? It is 8. Okay, so between 8 and 7, what is the minimum? The minimum is 7 and minus building height. So it will hold 0 water. So building number 7, building with height 7 will hold no water because the water level is restricted by building number 6, which is of lower height than 7. So 7 will hold no water. Getting it? Let's do a better way. You will understand it better, okay? So what is a better way of doing it? So first tell me the complexity of this approach. How much time we are taking? See, you are running a loop, right? You are running a loop which is n times, and this is done inside a loop that is running n times. So it is order of n square. Absolutely correct. It is absolutely correct. So this is order of n square. Great. Now the idea is that we need to know the maximum element 0 to I for every I. This is what I need to know. Okay, that is one value that I need to know. And second value, I need to know the maximum element in the range from I to n minus 1 for every I. for every I. Okay. If I somehow know these values, my work would be easy. Can I use the carry forward idea here? How? Let's say our array was, this was our array, right? So let me just copy this. Okay, let's copy this. It's okay. Fine enough. Let me say this is my array. And what I'm doing, I'm computing the maximum from the left, from 0 to I. What is the maximum you have seen so far? So come on, you have to tell me at every step. So what is the maximum seen so far? 7. Again, 7. Again, 7. Again, 7. 7. 7. 7. 7. 7. 7. The maximum so far is 7. Okay. Basically, what I'm doing, I'm saying that left of I is maximum of the current element AI, or the previous that you have seen, that is left of I minus 1. Great. What is the maximum in the range from the right, that is from I plus 1 till n minus 1, from let's say I to n minus 1, not I. So we need to start from the right. What is the maximum we have seen so far in this direction? So what is the maximum so far? 5, again 5, again 5. For 6, it's going to be 6. For 0, it's going to be 6. Again, 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 it's going to be 6. And here it would be 7. Okay, from I to n minus 1. Great. Now you got this. Now what do these numbers represent? So these numbers represent that, okay, for a building with height 0, the maximum in the left is 7, the maximum in the right is 6. Does it make sense? For this building too, the maximum building height in the left is 7, the maximum building height in the right is 6. It does represent it. Okay, great. Now what we said I will take minimum of b1 b2. So these numbers are nothing but b1 b2 for every building. So what is minimum of these two? It's 7. Okay, these two. Minimum of 7 and 6, 6. Minimum of these two, 6, 6, 6, 6, 6, 5, 5, 5. Great. Now how much water this will hold? So that means I got to know the water level. So if I subtract the building height, so 7 minus the building height is 7, the original array. Building height is 0, building height is 4, building height is 2, building height is 5, building height is 0, building height is 6, building height is 4, building height is 0, building height is 5. So if I subtract and add all these terms, that will give me the water level. Yes or no? 7 minus 7, 0. So no, 0 means no water on the top of this building. 6 minus 0 means 6 units of water in this level. Okay. So 0 plus 6 plus 2 plus 4 plus 1 plus 6 plus 0 plus 1 plus 5 plus 0. 5 plus 1, 6, 6 is 12, 13, 13, 17, 19, 20, 25. This comes out to be 25 units. Absolutely correct. And so we got to know the water level at IAT building. So what we did? So in the first loop, we built the left sum, the left max, we built in order and time. The right max, we built in order and time. Okay. And finally, we computed the water level uh, by iterating over all the buildings 0 to n minus 1. We said okay, water level is nothing but water plus minimum of left max of I, right max of I, and minus the building of I. That's it. So again, this will now take how much time? Order of n time, because now these values are computed. These values are pre-computed using the carry forward technique. Got it? So we optimize our solution from order n square to order n using some extra space, which is order n space. Great. Got it? Is rainwater trapping clear to you? Uh, Suppose we get an interview question and we have already seen that question. Should we give them the brute force solution first, then the optimized? See, it is always better to start with the brute force approach in an interview, because that shows your problem solving process. Okay, no one gets to know the optimized process in the first shot. Okay, so right now, if I started this rainwater trapping problem with the logic that okay, if I do this, I need to get the maximum. Then I say, okay, this maximum part can be optimized using something I've learned, prefix sum or carry forward. So I implemented that technique to reduce the time complexity. So ideally, you should do this. And secondly, if you have seen the question, see, you can fake it, but there are high chances that you will get caught. So in my case, while interviewing for Amazon, I was given a question which I already knew. So I told the interviewer that this question is inversion count and I have solved it. So he changed my problem to something I have not seen. So that is what I would do. I would inform the interviewer that okay, I've seen this problem. Uh, if it is exactly same, okay. If it is a variation of the problem, then it's okay. You start with the basic approach and try to optimize it. Okay, pretty clear. How much time we are given for each such question? So generally, if suppose rainwater trapping is your interview problem, so when I appeared for Google's for problems like these, you had one interview round. That means uh, around 40 minutes were there for each problem. So one round, one question, and yeah, difficulty level was medium. So for such a problem, you're expected to get somewhere around 30 to 40 minutes. Okay, great. So since we are in a class, I can give you a lot of time because we want to cover so many problems. So we'll do one more question today, uh, and then we'll give you the break for from today's class. Okay, you have to write pseudocode or the complete code. So you can start with pseudocode, which is okay, but you might end up. So if it is an online interview where you have the access to code editor, you are supposed to write the complete code, which may not run. That's okay. Means you can make some assumptions like okay, if there is a sort function, I can say sort an array. Okay, you don't really need to write the complete syntax. That's okay. You don't need to write import java.util.scanner. That's okay. So it's more or less pseudocode only. And if you're given an online editor, you can use the syntax of any language, C++, Java, Python. That's also fine, right? So preferably when I appeared for Google, I did all the rounds in C++. But again, that being said, language does not matter. They gave me a choice. So my first language was C++. I did every round in C++. Okay. And not worrying about the header files and imports. I just wrote the algorithm logic in C++. That's it. They won't ask you to run the code on test cases and stuff. They will just ask you to dry run it on some examples. All right, so let's do the final problem for today. Given a binary array of size n, okay, we can replace a single zero with a 1, find the maximum consecutive ones that we can get in the array. Is the question clear? We have a binary array which contains zeros and ones. For example, I have a 0, so we are having zeros and ones in the array. So 0, 1, 1, 1, 0, 1, 1, 0, 1, 1, 0. So you can replace at max a single 0 with a 1, and you have to find the maximum consecutive ones that we can get in the array. Consecutive means without a gap. So can you tell me what would be the maximum consecutive ones in this array? See, if I replace this 0, I will get 4 ones, which means these 4 ones. Okay. Or I can say if I replace this 0, I'll get these 3 and these 2. That would mean how many ones? 3 and 3, 6. Okay. If I replace this 0, I'll get these 2, and this. I'll get 5 ones. And if I replace this, I'll get only kind of 3 ones. So what is the maximum out of 4, 6, 5 and 1, or 5 and 3? So of course 6. So the correct answer is 6. So that is what we need to find. Now start thinking about what could be a possible way to approach this problem. Any ideas? Mm, prefix sum. Not sure how the prefix sum would be helpful. Okay, just think in terms of brute force approach. What we did, what we just did to solve this example. What would be a kind of a brute force approach? Did I say that I iterated over entire array? And if I get a zero, I counted how many ones I can form. How many ones can be formed? This is what I did. Yes or no? Now suppose I was iterating over the array and I see, okay, there is a zero here. Then how do I get how many ones, how many consecutive ones I have? Who will tell me? Can I simply say the number of ones for if I replace this zero, if I replace this zero, can I say the number of ones would be nothing but the consecutive ones to the left of it plus the consecutive ones to the right of it plus 1 if I replace this one? Yes or no? Yes. Does it make sense? Okay. So what I need to do, if I need to count consecutive ones to the left, so I need to start from, let's say this index is I. So I need to start from I minus 1 and move left until I hit a 0. For the right part, I need to start from the index I plus 1 and move right until I hit a 0. And that will give me the count of left and right. And I add 1 to it. So this will give me, okay, if you replace this 0, this is the number of ones I will get. So can we build this approach in code? Right. And let's try to do it. Okay, let's try to do it. So can I say I'll iterate over the entire array. So I have for I equal to 0, I less than n, I plus plus. Now if the element ai is a 0, if ai is equal to 0, what I will say? I'll say, okay, L is the count of zeros in the left. Count zeros in the left. Okay. And R is the count of zeros in the right. Left of I. And count ones in the consecutive ones. Okay. So count consecutive ones in the left of I and count ones in the right of I. Okay. So if then I can say, okay, what is the maximum answer? So I can say, okay, answer is 0, and here I can say answer will be maximum of answer and L plus R plus 1. Does it make sense? Okay. Now, how do you get this? Can we simply put a loop? Can we simply put a loop? Sheetal says last start. What is last start? Okay, so basically it is simply saying that, okay, last statement. So this is basically saying that, see, we want to check now, we want to track for all the zeros. Let's say this gives us 3, this gives us 6, this gives us 4. So I'm saying answer was 0. Then I got 3. So I updated maximum. Now I got 6. So 6 is max of 3 comma 6. So it is just as same as saying that if my answer, let's say, uh, current answer is L plus R plus 1. If current is greater than the answer so far, let's update our answer equal to current. Does it make sense, Sheetal? Like it is the same thing, right? So max function is taking a max of two values. What is the largest so far, and what is the current largest? So whatever is bigger, it will put it in answer. Okay, so that's what we are doing. Same as largest of n numbers. But now, how do I find this? Okay, so in order to write this, can I put a loop? Can I say the left count is 0, and I can say uh, while while what? While array of I, not actually array of I. Let me take another variable. Let me take j equal to I minus 1. While array of j, this is equal to 1. What I am saying, let me go back j minus minus and let me increment the count L plus plus. Does it make sense? Suppose you got a 0 here and there were ones here. So I said, okay, start from this index, j is I minus 1. Till you're getting a 1, please go back and increment the left count. So 0, 1, 2, 3, 4. So left count will be finally 4. Okay, are you getting it? Similar thing, you do it for the right. You say, okay, the right count is 0 and j is now I plus 1, while, and you also need to ensure that and j is greater than equal to 0. We do not go beyond the 0th index. Okay, we do not go beyond the 0th index. So you say while array of j, actually this should be the first condition. If j is negative, then you cannot check j. So you should write while array of j is greater than 0 and aj is 1. While j is greater than equal to 0 and aj is equal to 1. Something like this. Similarly, you can say while, since you're going right, you need to ensure that you are not crossing the boundary of the array. So you are less than n and aj is equal to 1. So what do you need to do? You need to say, okay, I'm going towards right. So r plus plus and j also plus plus. J is also moving towards right. So if you have some ones here, you will count how many ones are present in the right part of this array. Okay. So now this will complete the code. So you put this part here, you put this part here. So can you tell me what is the complexity of this code? So the person who will answer this correctly will get a special shout out from me. You have to look carefully and answer. What is the time complexity of this code? What is k here? K तो कुछ है ही नहीं यहाँ पे. Siddharth? So people are saying n square, except Rishikesh, Rohit, and Siddhant, and Madhu, and Ramesh. So these people have claimed it's order n. So it appears that the time complexity is order of n square because we are using two nested loops. But that is the biggest catch of this solution. It's actually order n. Are you wondering why? Why it is order n? Ask me why. Why? Okay. Reason why. See, if you carefully see what we are doing in this code, okay? So let me try to show you through an example. Let's say I had 1 1 0 1 1 0 1 1 1 1 1 0 1 1 0. Okay. Suppose this was the array. Now you are you're doing this work only when AI is 0. Only when AI is 0. Okay. So that means when you came to this index, you simply did nothing and you bumped into the next place. That means you visited these two ones, okay, you did 2 units of work. But when you came here, you said, I will traverse uh, this part of the array and I will also traverse this part of the array, which is okay. Which is okay, right? This is what you traversed. Did you traverse the complete array? Did you traverse the complete array or did you traverse this part only? This part only because we are stopping when we hit a 0. So next element is 0, we stopped here. Okay, great. So that means you did some work here. Great. Now you came to the next place. Again, you're just going to skip it because this element is not 0. Now you came here. So how much work you are doing? Did you traverse this part of the array? Yes. You traversed this much part of the array, right? And you also traversed this part of the array. Good. We traversed it, right? And then you came here, did nothing, did nothing, did nothing in the outer for loop. Then you again came here. You said, okay, let me traverse this part of the array and let me traverse this part of the array. Okay. So then you came here, did nothing, then you came here. You said, okay, let me traverse this part of the array. Okay. Now, if you look effectively at max, how many times each element is visited? How many times each element is visited? No, it's not one time. See, if I talk about this one, right? So 0 might have discovered this one in this direction, and this 0 might have discovered this one in this direction. So at max, you're visiting an element 2 times, or if you include the outer iteration as well, in which you are saying, okay, I'm going to every index to check if it is 1 or 0. So maybe one more time, one time that. So at max, every element is visited at max 3 times. Okay, one times because of this for loop, and one times because of this while loop, and one times because of this while loop. So at max, every time every element is visited 3 times, not more than that. So that means if we are going to every element 3 times, we are doing 3n amount of work, and we are not doing n square amount of work, and hence the time complexity is order of n. Are you getting it? Okay. So n square would mean that every element is visited n times, which is not correct. Which is not correct. Okay. So do we need to optimize this solution? What is the time complexity now? Order of n. And what about space? It's already O1. Can we do better? Can we do better? Come on, let me know. Can we do better? The clear answer is no, because ON would mean that you have to look at least every element at once, right? You have to look at, it's already linear. Without looking at all the elements, you cannot say how many consecutive ones are there. So this is the best possible you can do. So hence we will not do any optimization to this solution, right? we can do 3n and 3n to 1n. You can think of some ways, but that will not affect the time complexity, uh, which is okay. So this is not bad. This is actually good enough. So if in some way you can optimize it little more, I would be more than happy, right? But this is a acceptable solution, even for an interview purpose. Okay, this is completely acceptable. So 3n is same as 2n and 1n. So it does not, the constant term really does not matter. Okay. All right. So with this, we are towards the end of today's class. Did you found the class useful? So we did not learn any new topics, but we just showed you how you can uh, implement the techniques that we learn to solve various problems. Prefix sum, sliding window, carry forward. Okay, all that stuff. Right? No class on this Friday. Yes, there won't be any class on Friday. Okay, Roshan says, what happens if I have a worst case like this? 1 1 1 1 1 0 1. So in that case, you will go here, go here, go here, go here, go here. You only did 5 steps, which is fine. Like you visited every element once, then you visited this 0, you went back, and you went here. So what is happening? And then you went here, right? So again, you visited every element only 2 times. Yes or no? So it will be 2n, which is still order of n. Roshan, it's not actually a worst case, it's a good case. At 0 only, na, you went back and forth in the array like this. For all other positions, you did not go. And even if there is a 0 in the beginning, you are not going to traverse the entire array. You are only going to traverse this much part of the array, like after this 0. Hence, it's not order n. In total, you are traversing lot lesser, right? Got it. Okay. So all right. So with this, it's time to say you good night. Bye bye, and we'll meet you next week. Okay. Try it out. Possibly you can use prefix sums. Long weekend. Enjoy the long weekend. Okay. But do not give up the practice. Do all the assignments. If you have any backlogs, clear them. Okay. Bye everyone. Good night. Good night. Good night.